All right, let's talk about the course. So we're going to go through all the details here and kind of get rolling. What I'm looking at right now is the bulletin board on the Mind Ordained page. This will be the main hub for the course. On that page, you're going to see an agenda for the week. That agenda is always my best guess. I already know today that it's what I have up here is wrong. We won't get that far. That's okay. We'll get there eventually. But that's always just my best guess for the week. Links. So if you look at the links, we have important links for the class. One of the things I do in my math class is every math class, I'm going to try to record the lecture. The link to the video of that lecture is going to go in here. Now, this being the last hour of the day, typically it takes a while to upload the video and then get a link. And so this might not be up there till the morning of the next day or whatever, since it's the last hour. But they'll get there eventually, I promise. Announcements, I got one with my contact information. We'll talk about these other links here in a moment. The syllabus, and then downloads I'll put in the archived agendas. So if you wanted to see what we did like 3 weeks ago or whatever, and then the syllabus sign-in sheet is there. I'll talk about what that is here in a few minutes, okay? Everybody cool? So far, so good? Pretty easy. Oops. And then let's take a look at the syllabus. We'll run through that and just kind of do the greatest hits, because you've probably seen enough syllabuses in the last 2 days to like ever again, right? All right. So I use OneNote in class. It's my primary tool to do notes. If you want to take notes in OneNote, that's perfectly fine. You're welcome to do that. So as long as you're using your computer to do math-related present computer things, we don't have any problems. If you're setting your fantasy line up and watching YouTube or shopping for prom dresses or whatever, we'll deal with that when it happens, but please don't do that. The way the course grade is set up, so 50% of your grade is going to come from tests, 10% from the homework quizzes. We'll talk about what those look like in a minute. 25% from the homework and 15% from the final exam. The grade breakdown, straight from the handbook. Extra help, CT is the best time. The mornings are now, when I wrote this, probably not as great. I have my daughter's going to lower school, so I have to get her there in the morning. And I can't get her there till like 7:30 as it turns into a whole thing. So it's like I'm barely getting here on time for first hour a lot of days. So to get the special certificate at the awards convocation, since this is an honors course, you need 93 or better both semesters. Homework. So I'm going to assign homework most days. For the most part, the homework is going to be part of a week-long problem set. Those problems would not be due until Sunday at midnight. We're going to turn those in using OneNote. And realistically, is Mr. Kulik up at midnight on Sunday to check your homework? The earliest he's going to get to them is like Monday morning. So if you're like running a few minutes behind, don't send an email. It doesn't matter. If it's there by Monday morning, everything is going to be fine. We'll talk about how we're going to use OneNote to submit things. Okay. Additionally, we may have some digital or virtual assignments that are dailies. These are going to be done through Delta Math, and we'll talk a little bit about more how those are going to work once I've got Delta Math kind of sorted out and figured out, but we'll figure it out together. But those we'll talk about the format for those when they come. Everybody cool? We'll talk about how to do the OneNote stuff here in a minute, okay? And again, these weekly homework assignments are just based on completion, right? Not right and wrong. The Delta Math stuff we'll give you some feedback grading things right and wrong. Although I think the way I'd like to set it up is just you've got to answer questions until you've gotten X number right. So if you're willing to grind, you can just get 100% on stuff. You know what I mean? Okay, late assignments. So here for the first week or so, the first month or so, we'll probably waive the 1 week late penalty. I get a lot of late assignments here early on based on just like understanding how OneNote works, and we'll be pretty flexible on that. Again, if you are a situation where I've graded something and you're like, hey, I think I had all this done and he gave me a missing or an incomplete or whatever, it's probably a sync issue on OneNote. We'll resync and you send me an email, be like, hey, I don't think this synced right. I think it should be good now. Can you check again? It's fine. Okay. After a week or after a month or so, we'll tighten that up. I'll announce, let you guys know that, hey, like, should have this figured out by now. Let's not, we're going to start charging penalties on these if you don't have it figured out. But for the most part, it's fine. Okay. And this is straight from the handbook or whatever. The homework quiz is typically, we're going to give one per chapter. They're going to be unannounced, although I usually give you a pretty good idea that, like, hey, by Friday, I might want to have the homework up through section 7 done. Like giving you a hint that something is coming, right? So it's not like totally unannounced, but these are based on the recent homework assignments and our closed book. I grade these on a 10-point scale based on overall demonstration of understanding. Homework quizzes are typically short, like 2 or 3 questions. If you get one question wrong, it doesn't mean you get like a 67%. It matters like how you got it wrong. So like if you got it wrong because you dropped a negative sign, it's like a 9 or a 10. You did A work, right? You made a mistake that was like unrelated to mathematics. You just made like a transcription error. You get one wrong and because you made an algebra mistake related to like previous learning, 8, 9, depending on the severity of the mistake. Like you get every question wrong, but you had like kind of the right idea or the right start for all of them. 7, probably. You have something in there that resembles a correct answer at some point, or like on the way to a correct answer at some point for one question out of all of them. 6, probably. Very hard to do really badly unless you're like literally not giving me anything that makes any kind of sense. Which again, based on the like, there's not a lot of warning. There's not a lot of like, what is this going to be? I think that's a pretty fair way to evaluate these things, is kind of on a soft scale where just like, am I looking at something that I'd consider A work, B work, C work holistically, right? Not looking for mastery on a homework quiz that's unannounced and like kind of a surprise is what even it's going to be on. You know what I mean? And again, the other thing to remember is it's the smallest part of the grade breakdown as well. So it's only 10%. The test will typically have 1 at the conclusion of each chapter. Again, partial credit awarded for most questions based on the merits of the work. If you're somebody that gets the extra time for testing or whatever, you have to set that up through counseling. I don't care how you want to do that, but I do ask that the testing is done all in one setting. Again, talk to your counselor and figure out like the best way to do that for you. Dress code, I'm sure you've heard enough about in the last 2 days. Computers is just copied from the handbook. Academic honesty copied from the handbook. Absences, if you're absent on a class day, you have the video for class. You'll have my notes from class in OneNote. You'll have on the bulletin board the description of what we covered that day and any assignment that might have been based on what we covered. Do you need to contact me on a regular class day if you're absent? No, it's all there, right? You can. It doesn't hurt, but like it's all going to be there. If you miss a homework quiz, again, these are unannounced. How would you know? Typically, I'm going to put in the missings on the homework quiz while the other people are taking them so that it's there as soon as I know that you missed it. If you need to make up a homework quiz, anytime during CT is fine. You don't need to give me advance warning, typically. And I'm happy to just, they're supposed to be like 15, 20-minute things. Lots of time in CT to get that done. Happy to do it. Let's make it easy. Nobody needs to schedule anything special. Just come by. If you miss a test, study hall or testing room are your makeup opportunities. Doesn't matter to me. All I'd ask is that within 1 week of your absence, you figured out when and how you're going to do that and let me know. So like it doesn't have to be done within a week, but you need to be like, hey, Mr. Kulik, I'm going to take it a week from Friday in my study hall. Fine. No problem. You know what I mean? At the conclusion of the semester, we're going to drop a low homework score, drop a low homework quiz grade, and we're going to give you the option to either take a doubled high test score or retake a previous test where the max score is capped at 85%. This doesn't happen until the end of the semester. We'll talk about it more then, about like how to choose which one might be best for you, or remind you of that option. But keep in mind that's the only retake that's going to happen outside of like astronomical circumstances, you know, or things beyond everyone's control. The plan this semester, we'd like to cover the first 7 chapters. Usually we can get through the 6 pretty comfortably. The 7th might be a little dicey. That may end up wrapping into second semester. And then this is my disclaimer that like if I need to change stuff because it doesn't make sense for what's going on, we'll change stuff. The last page is the syllabus sign-in sheet. This is just you signing and telling me that like, hey, I read the syllabus and this is fine with me, and I showed it to my parent and they have seen it. Okay, this will be your first homework assignment. This is due Sunday at midnight as our first homework check. We're going to turn this into OneNote as a good practice of like how to make sure that happens. Any questions so far? Okay, well, let's set up our OneNotes and talk about how we're going to do that. So take out your tablet for me. Get that thing fired up, and then open up Microsoft Teams. If you don't know how to find Microsoft Teams, the easiest way is to use the search, the magnifying glass, and just type in Teams into the search bar. Should pop right up. If you don't have Teams installed on your computer, if from the search bar you pick Web, you can load Microsoft Teams through the website and do the same thing. It might run a little slower because you have to go through the Wi-Fi to access it or whatever, but it still works. Either way is fine. Once you've entered Teams, make sure on the far left navigation panel that you're on the Teams tab. And then I'll give you guys a second to get there, and we'll reconvene in a minute. All right, how are we doing? Are we at a screen that looks similar to this? Does everybody see an 8th hour honors trigonometry box on their screen? Occasionally I miss somebody or there's a schedule change and I need to add somebody in. Is anybody missing the 8th hour trigonometry box? There probably, I don't know, maybe there won't be. I don't think I had any ads. I just had drops from this section. Everybody's good? Okay, if you change your mind, let me know. From this screen, we're going to click on the box that says 8th hour honors trigonometry. In the middle navigation pane, we're going to pick class notebook. That's going to load into the right navigation pane an image of Microsoft OneNote. Once that finishes populating, from the navigation bar at the top of OneNote, it says Open in Browser. You're going to click that drop down and select Open in Desktop App. You can ignore the pop-up that comes up. You don't need to do anything with it. In a few moments, Microsoft OneNote should open up and load in your shared OneNote notebook for you automatically. You might have even done this already recently, so it might not be an entirely new process. If anybody is stuck or something's not working right for them, let me know. I'll come by and take a look and try to help you out. But I'll give you guys a few minutes to kind of let those things load in. It sometimes takes a minute or two for OneNote notebooks to load in because it's all got to come over the Wi-Fi. Yes, sir?
Did you say open in browser or desktop?
Desktop app. Yeah. Did everybody get their OneNote to come through at this point? Anybody still waiting or get stuck? Okay, great. So if you're looking at your OneNote that's on the screen, you should see 3 tabs at the top. One says collaboration space. That's something I'll never use in class. The second one says content library. If you click on that, you're going to see that there already have 2 things loaded into the content library. One is the syllabus, and the other is the syllabus sign-in sheet. Remember that the syllabus sign-in sheet is part of the homework. Oh, let's pause. Let's go back a second. The things in the content library, I can edit, but you cannot. For you, they're read-only. Everybody's okay with that? However, you can copy things from the content library and put them into your editable sections of OneNote to do something with. Since the sign-in sheet is a homework assignment, what I would do right now is copy it from the content library and put it into your section. So I'm going to just hit copy. Well, actually, from the right navigation pane, I'm going to right-click where it says syllabus sign-in sheet and then hit copy. Arrow up and go to my personal section. If you look at your personal section of OneNote, you're going to see 3 tabs. Current homework, that's a section for things that have yet to be graded. Archived homework, that's a section for things that if you're going to save things that have been graded already, you'd move them over there. And then the last section is for notes and handouts if you want to use OneNote to do notes. You don't have to, but I put a tab there. So for you guys, I would move that syllabus sign-in sheet into the current homework section because you're going to fill that out and turn that in, and that's where it's going to go for the turn-ins for me. That's where I'm going to see it. Okay? Now, Alex, I'm looking in yours right now. Have you moved that sheet in there yet? You just moved it. How come I can't see it, guys? How does this work? Yeah, so your computer has to send that information up to the cloud, and then my computer has to pull that information from the cloud back to my machine. That's why your change hasn't yet shown up on my machine. It is coming in now. It took, about a minute for that to happen, probably? Maybe a little less. Yeah, something about that, though. Not an unreasonable estimate. Is there a way to make that go faster, make sure that that has actually happened? So the way to do that, you can force your OneNote to sync. The easiest way to do that is if you go to where it says 8th hour trigonometry notebook and you right-click. You can pick sync this notebook now. And you'll see this little green circle here that's on the book. That's telling you your tablet is syncing or your notebook is syncing. And when that little green circle goes away, the syncing would be finished. And you know that you've sent everything on your end up to the cloud. It's up to me on my end to make sure I've pulled it back down. If you are super, and there, it took about, 15 seconds or something to do that sync. But it's not continuously syncing all the time. It doesn't do that. It waits and does it periodically, like every couple minutes. Your tablet will automatically try to sync things. If you're a little type A and you're like, I really want to see that better than that little circle, if you pick Notebook Sync Status, it'll show you all your shared notebooks and you can sync all of them at the same time and gives you like a little status bar so you can really see if everything is finished syncing. And it'll tell you that it's finished and when it finished and all that jazz. So, the moral of the story here is, if you are turning something in on OneNote, before you are done, before you close out a OneNote, force a sync, wait for that sync to be completed before you close your OneNote. Okay? This is the number one reason why students end up with missing or incomplete homework assignments is because they go ahead and they do something and then they don't sync it and they close their OneNote and they're like, I can see it on my end. Why can't you see it on your end? It's like, well, it didn't finish syncing. Okay. All right, so we've talked about how to copy things from the content library into your notebook. Does that mean, Mr. Kulik, if I'm turning my homework into OneNote, does that mean I have to actually write my assignments in OneNote? No. You can, and that's fine. If you're good with that, I'm good with that. But you could also write your homework on paper. You could then take a picture of it and drop that picture into OneNote. Let's practice doing that. What's going to be the best thing to use to take a picture of your homework with? Your tablet camera is garbage. Use your cell phone camera. It is way better than your tablet camera. Probably your tablet camera will give you a picture that's unreadable. Okay? So let's practice this. Take out your cell phone. I know. It's okay. I'm telling you to do it. It's part of its practice. Take out your cell phone. Take a picture of anything. Doesn't matter what it is. Email that picture to yourself using your Notre Dame email account. I'll pause here while everybody figures out something to take a picture of. Hopefully it's an embarrassing picture of your friend. So once you've taken your picture, you're going to email that to yourself at your Notre Dame email account. Then you're going to go into your tablet and you're going to open up your email, and you'll see at the bottom there'll be a little attachment. You'll hover your mouse over that attachment to where there's the download button. You'll click download, and you're going to select a place to save this. My suggestion is to save this to the desktop, because what we want to have access to is the icon. Easiest place to find an icon is if it's just sitting on the desktop for you. So I would save it to the desktop. And once you've done that, you can make a new page in your current homework tab and just drag the icon into the big blank white space in the middle and let go, and select Insert Printout. OneNote will do some gobbledygooking with, in this case, Adobe, because I put in a PDF, and then it just drops it in there. Okay? Alex, I was doing this example in your notebook, so I'm going to delete that stuff that I already did there.
How do you flip it? If mine came in sideways.
Yeah, so if your picture came in sideways, if you right-click on your picture, one of the options is rotate 90 degrees or whatever in both directions. You just keep rotating it until it looks right side up. So all you need to do is drag the icon that you saved into OneNote and just let go. And then you'll pick Insert Printout, and it's done. It just pops up in there. You're welcome.
Ew, it's so bad.
All right, did everybody get their picture into OneNote? Working on it. Okay, once you've gotten your picture in, you can just delete it. I don't actually need to see this picture that you've taken. It's just for the sake of practicing doing this. Since some of us have never done this before, I just wanted to give everybody a chance to do it. Because I find that probably half or 2/3 of students would prefer to do their work on paper and take a picture and drop it in. Totally fine. Just want to practice it so you're good at it. One thing to keep in mind as far as syncing goes, what's going to sync faster? The stuff you handwrite into OneNote or a picture you've dropped into OneNote? The handwritten picture file is huge. So if you are electing to go that route, keep in mind it's going to take, the syncing is not going to be super duper fast. You're really going to want to make sure you do the force sync at the end before you close out. Or else probably I'm going to be staring at something that labeled as homework with it as a blank OneNote page on it, because the pictures wouldn't have come through. You know what I mean? Does anybody have any OneNote questions? Yes.
So if we choose not to take a picture, we have to do all the work on the blank OneNote piece of paper?
Yes.
Okay.
Yes, that's also an option. Either one is fine, whatever you prefer. Some people like OneNote, some people don't,
Okay.
you know. Okay. Everybody happy so far?
Yes.
Cool. Questions so far? We're still good? All right. What is this stupid toolbar? Yeah, we'll just get out of the way. I don't care what it's doing right now. All right. While you have your tablets out, let's go back to go to our Notre Dame page for this class. So my Notre Dame, Honors Trig and Pre-Calc 8th hour. We're going to be looking at the links section. From that links section, I want you to click on the Delta Math registration. When you do that, it's going to be automatically come up with the course and teacher code in there. All you need to do is hit register with Google, pick your Notre Dame email account, and we're done with this for today. You've just registered for Delta Math into my classroom so I can assign stuff to you. Nothing's going to happen today, though, because first time we use this, we're going to just use it together in class because it's my first time using it as a teacher. It'd be your first time using it as a student, probably. So we'll do it all together so that when things go wrong, you can tell me about it and we can try to figure out a better way to do it, right? Okay, so again, you just pick click the Delta Math registration, hit register with Google, pick your Notre Dame email account, and I think you're done, right? Took like 3 clicks or whatever. Anybody get hung up on that? Anybody still clicking? Cool. From here on out, anytime we go to Delta Math, we'll use the regular Delta Math link where now you have a login, so you just log in through Google at the Delta Math link. So the registration, we'll never use that link again after today. I might even get it out of the links list. But I'll probably wait a week or so to make sure that if people were absent, like we had somebody absent today, that it's still there for them. But eventually I'm just going to delete that out of there. Cool? All right. I think that's good for the course setup stuff. So let's actually start mathing. What do you guys say? Yeah, do we have to? No, we don't have to, but we're going to. All right. So, that's what I want to do. Let's go like that. All right. So when I do these notes, notice where I'm at. I'm in the 8th hour Honors Trigonometry notebook in the content library. What does that mean to you? Whatever I'm writing here, you guys have. Okay? So when it comes to in class, do you need to write down any of the notes? It's up to you, right? I was a student that if I wasn't actively doing something, I couldn't pay attention consistently. So I would, even though I know the notes are there, I'd probably still write my own notes even if I never looked at them again, because it just helped me pay attention. Now, some students are like, if I'm sitting here writing notes, I'm not listening to what you're saying and I don't register anything and I walk out empty. All I have is a bunch of stuff written down. If you want to just sit and listen and rely on the stuff that I'm writing as your notes, totally fine with that also. Do what works best for you. Experiment if you want to. Figure out how you learn best. You don't have to worry about taking notes because my notes will be there. But if you're like, I need to take notes to pay attention, I would certainly do that. Know yourself, though, and what you need. Everybody cool? It's a nice bonus, though, right? You have all the notes, and you have the lecture again on the video. If you need to go back and re-listen to something like, hey, he did this problem in here, I need to see that again. You can always just kind of fast forward through YouTube until you find where you're looking for. Cool? All right. It's a good deal, right? All right, let's start. We're not going to start in with any of the actual course content here right away. We're just going to start doing some like foundation stuff that we should remember from previous courses that are kind of be our jumping off point for this course. So this is today what we're doing is nothing like expressly course content, but it's like the lead-in stuff to what we're going to be doing. All right, so this course is trigonometry. When we look at the root word here, what does that remind us of? Triangle. Yeah. And then like the suffix, ometry, what does that mean? Go ahead. You can do that too. You got a bleeder?
No, I got that.
Oh, that's a hassle. Yeah, go. You'll need that.
Yeah.
It's hard to participate if we can't see, right? He's still talking to me. Just being hypothetical there. That's funny. Ometry. Okay, like same suffixes in geometry, which be like the study of, right? So trigonometry is like the study of triangles. Okay, it's a fair descriptor of what we're going to be doing. When was the last course where we encountered triangles on a regular basis? Geometry. So that's going to be our jumping off point. So, thinking back to geometry about triangles, what facts, theorems, definitions, names, anything that we remember about triangles from geometry? Okay, so I'm going to be a little bit more general with that. So we had congruence and similarity theorems. Okay. Hold on. We're gonna be really. We need to review what all those things mean, right? What does it mean for two figures to be congruent? Yeah, it's essentially the figures are identical, other than the names of the vertices, right? So all the same side lengths, all the same angle measures. Right? Congruence is basically equality in geometry land. They're basically the same thing. In fancy mathematics names, we call those equivalence class or equivalence relations that satisfy a bunch of properties. If you have something that satisfies these properties, we'd call it an equivalence class or equivalence relation, excuse me. All right. That's neither here nor there. This one, this was similarity. What does it mean for two figures to be similar? Okay, the angles have the same measure, but what about the sides? Different, but still we would say, yeah, so I'll call that proportional. Say proportional side lengths. So just as an example, what do we mean by proportional? So if we have two similar figures, one, say the triangle has side lengths 3, 4, 5, and the other triangle has side lengths 6, 8, 10, we'd say that those two figures are proportional because 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10. That there's a scale factor of 2 between the two figures. It's kind of the same thing that you saw with dilations, right? If you dilate a figure, the result is a similar figure. It's the same shape, it's just a different size. Okay? And then, I'm sorry, who gave me the side? Okay. Yes. What was your name again? Ariana. Thank you, Ariana. So side angle side is a theorem for both congruence and similarity. Keep in mind, though, for congruence, you have to show the sides are congruent. And for similarity, you have to show they're proportional, but still had the same name. Okay. Were there any other theorems here? Yes, sir.
Are we trying to find like one or one that works for both?
Either is fine.
Okay, well,
Okay, so really just angle is enough, right? Two angles is the same thing because the third is obviously, if two of them are the same, third has to be the same. Absolutely. Yes.
Side, side, side.
Side, side, side works for both. Again, for congruence, you're showing the sides are congruent, and similarity, you're showing that they're proportional, but had the same name. Anybody remember any others? There's still some more. Angle side angle is a similarity one. Now that's equivalent to just angle side angle is a congruence one. And you could do that for similarity, it'll work, but like all you need are the two angles, but it's fine. Angle side is also a congruence one. And again, that will work for similarity, but all you really need is angle. You don't need the side. You could show it, but you don't need it. Anything else? There's one more special congruence one. I think your textbook calls it the hypotenuse leg theorem. This is a special case of SSA, where the A in this case has to be 90-degree angle, has to be a right triangle. In general, SSA does not work as a congruence theorem. We'll see later on this semester, I'll show a concrete example of two triangles that have two congruent sides and an angle that are not, obviously, clearly not the same triangle. And in fact, we'll set it up in like the geometry software, so like you can drag the angle and make it 90 degrees and see it turn in from two triangles into one triangle. It'll be pretty neat. But you probably talked about that in your geometry class back then too. Maybe. Who knows? Doesn't matter. Okay. I think that wraps up triangle congruence and similarity, right? That was about all the review there. What's another geometry triangle related topic that you might remember? Pythagorean theorem. Okay. What does the Pythagorean theorem say? I think there's a little bit more to it than that. Does that always work? A squared plus b squared equals c squared? That's the quadratic formula, I think. What? Right triangle you must have. Good. So Pythagorean theorem doesn't work for non-right triangles. And what about the side lengths that are, where do I plug in the side lengths for A, B, and C? C has to be the hypotenuse, yeah. So we'd say in a right triangle, the sum of the legs squared is equal to the hypotenuse squared. And as I'm writing things, if it's ever unclear, like my penmanship I know is not always the best, and it gets worse as the day goes on. So by 8th hour, I had fully realized that sometimes it gets terrible. If you can't tell what something is, or you're not sure if it's too small or whatever, please stop me and ask. If I ever look upset about that, it's just that I'm frustrated with my own inability to write clearly. It has nothing to do with you. It's me being pouty about myself and my own inadequacies. Okay? So if I make a face, it's not about you, it's about me. Just being clear. Great. Pythagorean theorem, everybody's cool with that definition, right? We covered the two places where students will make mistake is applying it incorrectly in a non-right triangle and then plugging the numbers in the wrong places. What else do you guys have for triangles? Yes, Tessa. Sohcahtoa, yeah. And what does Sohcahtoa say? Yes, sir.
Sine, so it's opposite over hypotenuse, and it's cosine, and then adjacent over hypotenuse, and then tangent opposite over adjacent.
Great job remembering the acronym, but there's a little bit more to it than that. What do we need?
It has to be right triangle.
Okay, so we still need a right triangle. So again, just being picky now, you had absolutely the acronym down. And can I use any angle in that right triangle? Nope. I can't use the right angle, so we'll say with acute angle, and I'll call that angle theta. So that circle with the line through is the Greek letter theta. Common convention is when we name variables for angles, we use the Greek letters, and name variables for side lengths, we use the regular alphabet letters. So there we can say now sine theta is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. And tangent theta is opposite over adjacent. So what do we observe here for sine, cosine, tangent? What type of number are they operating on? They're operating on angle measures between 0 and 90 degrees, right? Opposite, adjacent, hypotenuse are what kind of quantities? They're side lengths from triangles, right? So they're positive numbers for sure, because you can't have a negative side length, right? So just as a little illustration here, so let's say we have this triangle here, ABC, and I want, when we name a triangle where we name the vertices with capital letters, how do we name the sides then? Lowercase letters.
Of the side of the wall angle opposite.
Good. Of the vertex opposite that side. So for big A, this side would be little a. For vertex B, this side would be little b. And for vertex C, this side would be little c. Everybody's okay there? So if I wanted to do, say, sine of angle A, what would I write? Which side is opposite and which side is hypotenuse?
Little a.
Little a over little c. And if instead we did sine of B, we would write little b over c. Yep. Everybody cool with that? Remember that the opposite, adjacent, hypotenuse is relative to the angle you're taking the sine or cosine or tangent of. That all ring some bells? Very good. All right. What's next? What other triangle stuff can we remember? Still some good stuff that we haven't mentioned. You guys have got my two favorites though already. Okay, so yes, there's special right triangles. And there's two of those. So one of them is the 30, 60, 90. And the other is 45, 45, 90. Yep. So let's do these one at a time. So for a 30, 60, 90 triangle, the side lengths are x, x root 3, and 2x. And then for 45, 45, 90, the side lengths are x, x, and root 2x. And when I write my radicals, I always put the radical part at the end so I don't get confused as what's under the radical and what's not under the radical. It's the same thing as saying root 2 times x, though. You know, I just write it that way. While we're on the topic of, or while we're talking about this, I'm going to point out another geometry fact that's helpful to remember which side goes where. What do we know about the relationship between the angles of triangles and the side lengths?
The base side will be across from the biggest angle and smallest from the smallest angle.
Great. So we say the sides of a triangle are proportional to the opposite angle measure. So as Braden had said, that means the biggest side is across from the biggest angle, the smallest side across from the smallest angle, and the medium side is across from the middle angle. So how does that help me remember where the x root 3 and 2x go? If I look at the coefficients on the variables, 1, root 3, and 2, if I just put those in order, 1 is 1, root 3 is like 1.69, and then 2. So 1 is the smallest, that should be across from the 30. 1.69 is the middle, that should be across from the 60. 2 is the biggest, that should be across from the 90. And you can do the same thing for the 45, 45, 90 triangle, where root 2 is 1.41-ish. Again, bigger than 1, so it has to be across from the hypotenuse. That's how I remember them. Some people remember that the root 3 is next to the 30. That works too. Okay. A couple more good ones still sitting out there. Let me give you a hint. How do you name a triangle? There's 2 ways to kind of classify or name triangles. One by angles and one by sides. Yep. Okay, so what are the different names we can give a triangle based on its sides? Yep, that's one. That's not by side, though. That is one of them. Scalene is another, and equilateral is the other. What do each of those ones mean? Excellent. Very good. So then if we do the same thing by angle measure, what are the 3 ways to classify by angle measure? Acute, obtuse, and right. Yeah. So for example, if I look at that 45, 45, 90 triangle, you could call that a right isosceles triangle because 2 sides are the same length and it has a 90-degree angle. Everybody's cool? And the 30, 60, 90 could be a right scalene triangle since none of the sides are the same length, but it still has a 90-degree angle. Okay. One more good one. So how many right angles can a triangle have? 1 at most. Why can't it have more than 1? Great, that's the one I'm looking for, is the triangle sum theorem. It says the sum of the interior angles in a triangle Okay. I think that covers all the big points that we'd probably need to worry about. There'll be, obviously, there's other stuff that'll come up here and there, but we'll just kind of review that as it comes. So using this information, here are actually thinking about this information, let me say it that way, I have a question for you. What's the relationship between Sohcahtoa and similar figures? Okay, that's true, but that just kind of dances around. Like, how are they, like, these two things are fundamentally related in a way beyond that. Braden?
Sohcahtoa is used to determine the ratio between sides.
So let's look at this example, right? We have two similar triangles. That's kind of on where I'm going. Let's say we have this triangle 3, 4, 5. Call that triangle ABC. And then I have this triangle, DEF, and let's say that's a 6, 8, 10 triangle. So clearly, right away, we can say that triangle ABC is similar to triangle DEF, since 3 over 6 is equal to 4 over 8, which is equal to 5 over 10. That's just side-side-side similarity. Everybody's cool with that? So if I take sine of A, that would be opposite over hypotenuse. And I do sine of D, that would be opposite over hypotenuse. What do you guys notice about 6/10? Yeah, that just reduces down to 3/5. And what we're seeing is that sine A is equal to sine D. So what we observe is that all similar triangles, the values of sine, cosine, and tangent of the corresponding angles are going to be equal. In fact, that's how we've designed sine, cosine, and tangent, is they're just literally a map. If I know a right angle and one acute angle, I know that all triangles are going to be similar to those. And I can just take, okay, for this specific angle measure, for the acute angle, I'm going to map that to this specific ratio of side lengths, because every triangle that has that right angle and angle measure has that exact same ratio of side lengths. So we've done that mapping for every angle between 0 and 90 degrees. Does that make it a little bit clearer, that relationship? Now, that's something that, even if you did it in geometry, is a fine point that's kind of missed. Is that really the tie-in between those two ideas? Because they happen at very different times in the semester. So the problem here is, in reality, do we have angles bigger or smaller than 0, or smaller than 0 and bigger than 90 that we might care about? Sure, right? What's the biggest angle you might care about? Period. In reality, like in the real world. 179, bigger than that. Bigger than 360. Wait a minute, how can you get an angle that's bigger than 360? Yeah, so think about, you got exactly the right ideas. So think about your car, right? How does a car work? Takes chemical energy, converts it into kinetic energy. That kinetic energy spins the drive shaft, and that energy motion is then transferred to the wheels. Now, that's a really pretty dumbed down version of it, but that's the gist of it. If we take how many times that drive shaft turns in, say, or how many degrees that drive shaft turns in 10 seconds, it's going to be a lot of revolutions, right? Could be thousands or millions of degrees that drive shaft turns in just a few seconds, right? Because it's going really fast. Everybody's okay with that? We can see there that really you could have an angle that you might care about as big as you want. We have lots of machines that have spinning parts in it. That can happen all the time from an engineering perspective, right? Is that clear that we might care about angles as big as you might want? That could happen in the real world. What about smaller than 0? Would that be something we might care about? So think about the same example of the car. Maybe let's say this is positive. What would if we put the car in reverse, its drive shaft spins the other way, might refer to that as negative angle, and you might have a negative angle as small as you want, right? Because again, that can spin lots and lots and lots of times. So again, what we'd like here is to be able to take sine or cosine or tangent of angles of any size, all the way to positive infinity, all the way to negative infinity. But to do that, we need a different definition. We need to break outside of the right triangle definition that we used in geometry to define sine, cosine, and tangent, and generalize that definition so that we can apply it to angles of any size. That's going to be really the first semester, or half of first semester is going to be building that out carefully and filling in all the blanks along the way on how to do that and how to do like the corresponding techniques with that, with our new definition. Then we'll spend the second half of first semester like doing some application of, okay, we have this new powerful definition. What can I do with this? And we'll look at algebraically kind of how we can manipulate these things with new definitions and the new things that we might be able to evaluate and do with it. That's really going to be most of first semester, is that concept. But it's really exciting, right? Like this is, and it's a fundamental part of how mathematics is done. You define something in a very narrow situation, and you say, okay, that works and it works very well. Can I extend this at all? Can I do some more with it and do some more and see how broadly you can extend that definition out and still have it work for everything below it, but now include new stuff above it, right? So like when you're in elementary school and you learned, like division, you started with division of things that were purely divisible, like 4 divided by 2, right? Things that were whole number divisible. And then you extended that into things like 4 divided by 3. Now it's the technique you used to do 4 divided by 3 still worked for 4 divided by 2, but it, I added the idea of like a remainder or repeating decimal or whatever, and it can cover more technique. This is what we do over and over and over again in mathematics. Does that feel okay? You kind of see the analogy that we're drawing there? Okay. That being said, our starting point is this right triangle trigonometry that we did in geometry. So let's just kind of do, for the next few minutes, let's do some problem review of these kinds of questions from geometry. I know, but again, if we have a problem with any of this stuff, it makes what we're going to get into here in a bit a problem. And so is the functioning of my stylus apparently right now. So give me a moment. Oftentimes, if I'm having trouble, if I just take the battery out and put it back in, it just magically fixes itself. Have you noticed that? There we go. Ugh. I think we need a new battery here. All right. So let's say we have a question like this. This should look like a familiar geometry question, right? What can I do with this? Anybody got any ideas?
Like side, you could do side for it.
Can I? Look very carefully. Yeah, it's not a right triangle. It looks like I've drawn it as a right triangle, but what is it missing? The little right angle symbol in the corner. Can we do anything until we have that? No. So let's pretend it is there now. Now, yes, we can do sine. How did you come to decide that sine was the one that we wanted to do? Yeah, relative to the 38, the side we know is opposite. The side we want is hypotenuse. Everybody's cool there? At this point, the geometry is done. It's algebra time now. To solve this equation for x, what should I do first? Multiply by, not 16, x. Yeah. I want to get that x out of the denominator. And again, perfectly, I love that we're yelling things out. Please continue to do so. If you yell out the wrong thing, that is totally okay. That's the point of doing this. It's all review. I don't expect any of this to still be like 100% mastered. That's why we're starting here and doing things that like you did a year and a half or 2 years ago or whatever, right? Because it's been a long time and it's okay to be rusty. Next up, what should I do? Very good. Divide by sine 38. Remember, sine 38 is just a number all by itself, right? It's just some crazy decimal. All we need to do is divide by that. And then it's calculator time, right? Since I'm typing in a sine, cosine, or tangent in my calculator, what do I have to be careful about? Not the parentheses per se. What was that? Yeah, the mode of our calculator. So there's two modes related to sine, cosine, and tangent, degree and radian. Which one should we be in now? Degree. How did you know that? Because the angle's written in degrees. It's that simple. To change the mode of your calculator, you press the mode button right next to the blue, and then you'll just want to make sure that the highlighted section says degree. If it's not highlighted, just move your cursor down and press enter on degree, and it'll highlight that up. And then I like to type this in so that it looks like a fraction on my calculator. The easiest way to do that is press alpha. That's the green button, and the y equals. That opens up the fraction option. The first one is just the regular numerator over denominator fraction. And I can type this in exactly as it looks like on my calculator, which allows me not to have to muck around and worry about the fractions. I can just type, or the decimal, I'm sorry, the parentheses is what I'm trying to say. I can just type it like it looks, which is super helpful, especially when things start getting complicated, right? I can just type it the way it looks. So my answer here is 25.98. If I asked you to round that to the hundredth, what would you write as your answer? 25.99. Very good. So I'll just write that we used our calculator to go from that step if you go back to look at it. Is this all ringing bells? Not so bad? All right. Make that a little neater, I suppose. Actually, let's put the 7 here. Oh. I'm not trying to trick anybody, so let's put the right triangle symbol on there. I made my point earlier.
Cosine.
Okay, so how am I going to set this up? So,
Cosine of x
very good.
is 7.
Excellent. So notice here that the variable is an angle measure, so that angle measure must be inside the trig function. Remember, we always take sine, cosine, and tangent of angle measures. Everybody's cool? Okay, so again, and this was, we had adjacent and hypotenuse relative to that angle x, right? That's how we knew to use cosine. Question so far? Okay. So we're solving for x. What do we do?
Multiply both sides by
Great. So we wouldn't say multiply, though. The verb you want to say is just take cosine inverse of both sides. But yes, that's dead on. I knew exactly what you meant. And again, there's no, no shame in not having like the perfect mathematics vocabulary on day one of class. Like that's normal to be expected. But notice that this is a function composition thing, not a multiplication thing. Okay, so we do this. Cosine inverse cancels cosine out. So we say x is equal to cosine inverse of 7/10. To get the cosine inverse, we press second and then the cosine button. And then I'm not going to bother with the fraction command because like 7/10 there's no confusion on that. So I get 45 point, what, to the 100th? 45.57. And I should write what at the end of that? Very good. What do you guys think? Does this feel familiar, or at least like coming back to me now? If you had handed me a bunch of problems like this to do initially, maybe not so much, but after going back and reviewing all this should be fairly familiar feeling, right? You typically spend a good amount of time in geometry doing this. I had a tough time last year because this part of geometry was the virtual time during the pandemic for last year's students. And we did not start here last year. I just kind of started and we got to this point and they're like, what? It's like, I just don't have this. This was during, and it's like, oh, okay, well, let's stop and we'll go back and do this. So this year we started here because it made sense to let's do this all and make sure everybody's on the same page. We're going to stop here for today. This looks like a good place feels like a good place to stop.